The shaded area in the Venn diagram above represents A, B, C, and D. So we have a representation of the diagram on the board here. Alright, so let us go through the answers one by one. P complement clearly would be the answer here because P complement represents everything outside of P. Whoosh, we throw that aside. Q complement, answer B, same thing, everything outside of Q. Definitely not what we see in here. So whoosh number 2, we knock that aside. Answer C, P union Q. Alright, P union Q would mean that we have everything inside of P shaded as well as everything inside of Q shaded. Now we clearly have everything inside of Q, but we don't have everything inside of P. So therefore answer C will not count as a proper response to this question, which leaves answer D as the only answer. So in a multiple choice, by the time you get to this point, you will know with some level of confidence using your process of elimination that P intersect Q would be the answer, right? But let me discuss this a little bit because there is a particular peculiarity in this question that I want to discuss. All right, now the P intersect Q that we are more familiar with would be this version. You have P, you have Q, right, and you have a region of intersection here. So this here is P intersect Q. This here is also P intersect Q. What is the difference between this P intersect Q and this P intersect Q? The difference between these two is that in this situation here, your Q is totally embedded inside of P. So in other words, your Q is a subset of P. Alright? So this is the region where P and Q are common, because in here you still have P, you also have Q, but it's just that you have the whole of Q and some of P, so you have the remainder of P outside. So in other words, what you will have is your Q, let us say, let me see, if you have a big P and a small Q. So you have the original intersection, and as you move this circle further into, you move this small Q further into P, you would get to the point eventually where the whole circle is inside of P, which is what you have here. And at that point, your Q would be a subset of P, right? In all of these cases, you would have a P intersect Q being the representation of the area. So just be mindful of that, all right? Be mindful of your regular P intersect Q, which we're familiar with, as opposed to your P intersect Q, where either your Q is a subset of P, or you can have it on the reverse, where your P is a subset of Q. Either way, something to look out for. So the answer to this question is answer D.